Here we go. We have a question, find the count of monotonic pairs 1. We have given a array of positive integers num of length n. We call a pair of non-negative integers, say array 1 and array 2 monotonic if array 1 is non-decreasing, means either the value is equal or the value is greater than the previous value, and array 2 monotonic decreasing means value either the value is equal or the value is lesser, and the summation of the current value should be equal to the element the given array current value. So we have to find the pairs. So let's take this example. In the first array, first case, a good pair is this. First array 1 is this. So this is non-decreasing, and the remaining values present in the second array. So it is non-increasing. Either a value is equal than the previous value or the value is lesser. So this is one pair. So we have 4 pairs. So we have to find the number of pairs. If the value is very large, so we have to take modulus. So let's build the approach. We have these two things, array 1 and array 2. So we have to think, if I am taking a value here, so its previous value should be lesser or equal. If I am taking the current value, so either its previous value should be lesser or this value is greater. So I can say previous value is 0. So I can take any value. I can start from 0, 1 and 2. Here this value or this value should be lesser than the previous value. This value should be lesser than the previous value. So I can take maximum value 1 in 9. So this value is lesser than the previous value or it is greater. And I have to take array 1 and array 2. Here I have two choices. Either I can take 0 from here. So on the second array I have remaining values. If I take 1 here, so on the array 2 I have remaining values. If I take 2 from here, so on the second array I have 0 values. So if I am considering 0 and 2 from here, so here I can either take 0 because this value is greater than or equal to. So if I have taken 0 previously, so I can take 0 here, 1 here, 2 here and 3 here. And if I am taking 0, so the remaining value is present here. In this case it is not valid because, as you can see, the previous value must be greater. In this case the previous value is lesser. Previous value is lesser. So this configuration is not correct. But if I take 1 here, so I have to take remaining values here. So if I take 0 here and 1 here, and here I have taken 2 and here I have taken 2. So this configuration till now is correct. So if I have taken 2 here, so I cannot take 0 here because either the value is equal or greater than the previous value. So the equal value is 1 or 2 or greater value is 2. So if I am taking 1 here, then here I have to take the remaining values. Remaining values is 1. So check, is this configuration correct? Means this value is lesser. Yes, this configuration is correct. Then go to next value, and we have exhausted all the values. So this is a valid configuration, 0, 1, 1, 2, 2, 1. That's how we have to find all the configuration. And so this will probably give you TLE. That's why we have to optimize it using dynamic programming. So let's take value. Suppose actually I don't need to create array1 and array2. I will just maintain a variable previous value. So previous value, initially it is 0. So here I have three choices to make. Either I can take 0, means the value is equal to the previous value, or the value is greater than the previous value. So I have taken these values. So here I have some values to take. This is the initial value. So just check what is the value we have taken previously. Previously we have not taken any value. So here it can be 1 in 9, and the remaining value we have to take. Suppose I'm taking 0 here. So let's take one by one. I have taken 0 from here, and let's go to the next index. The next index, I have to take the values starting from the previous taken value. So it is 0, or the value is greater. So all these values can be possible. And here I have to take the remaining values. So just check what is the previous value we have taken. Here the previous value, this is P1, let's suppose. So what is P2? P2 means previously I have taken P1 as 0. So the remaining values must be there on P2, means nums of I minus 1 minus previously taken value P1. So it is 2 minus 0, it is 0. So previously on array 2 I have taken the value 2. So here uh, the value is 2 here for P2. So here the value is lesser than or equal to, means if I am taking this value, so the current 2 value, if I am taking this value, let's say C1, C2, C1, C1 value is this, C1 value is this. So we have a for loop here. So C2 value, there are total n values, nums of I, and I have taken C1 values. So the remaining values are 3. In this case it is 3. So this value, this is P2. So what it says is, on the second array, this C2, actually P2 is greater than or equal to C2. If it is correct, then we go to next index, but in this case it is not correct. So I cannot take this configuration. This configuration is not correct. So next C1 points to this value 1. So if I taken 1, so total values are 3. If I have taken 1 in my first array, the remaining values are 2. So check if P2 is greater than or equal to C2. Next, in this case it is correct. So go to next iteration, means I have taken this value. So here if I go to next index, for this index I have taken this value as my previous value. So here I have to take either 1 or 2. I cannot take 0, because we have to fulfill this condition. So I am at last index. So either this value is equal to the previous value, or the value is greater. So here C1 points to this value, then this value. So that's how we have to fill our values. So now I think you got the idea. We have a function here, a function. We have a index. Next we have a previous value. It is previous one. Previous one means the value which I have taken previously in a first array. So we have a condition, and in this, if my I reaches n, means we have created a valid configuration. So we will return 1. else this is the previous taken value uh, in a first array. What is the value on the second array? Second array means p2. Whatever value is there means previous minus 1, and I have taken some values, so it contains the remaining value. So it contains remaining value, and for I minus 1 is not valid for all configuration, for all cases. Suppose we have 0 here, 0, so 0 minus 1 it is not valid. So for that I have to take this value, so that it will fulfill this condition, means p2 is greater than or equal to c2. So if this is not valid, I will take my maximum value. Next, I have taken some values previously, so here I have to take greater value or equal value, means c1 is either equal to p1 or c1 is greater than, means c1 will reach nums of I can take maximum current values, so c1 plus plus. I have taken c1 values. What is c2? C2 means whatever values left out, so nums of I minus c1. So this is the remaining values. The remaining values we have to fill in the second array, and we have to fulfill this condition, p2 is greater than or equal to c2. If this condition is valid, then we go to next index. Then we go to next index, and this will return us a value. So here I have to store in a answer variable. So we have a temporary value which give us the value present on the next iteration. So we will fill our values in a answer variable. At the end we will return our answer variable. So that's how we will solve the question. As you can see, I and P1 can be overlapping subproblems, can lead to overlapping subproblems. So I have to take care, and that's why DP comes in. Its first index is n. And what is P1? P1 means whatever the maximum value present. So just to find the maximum value in the array and fill here. It's time to code. So we have n and maximum value. Next we have a solve function. I n array and previous one, whatever value we have taken previously. If I reaches n, we will return 1. Else we will take, if I minus 1 is not valid, then we take the maximum value. Else we take this value, as I have discussed, and we also have to take answer variable. Next we have taken some values, previous value. For this current value, value 1, either the value is equal or the value is greater. So we will run a for loop. So this is value 1 we have filled in array 1, and whatever the left out value we have to fill in array 2. So this is value 2. If previous value, this is this condition, if previous 2 is greater than or equal to value 2, then we go to next iteration. So I plus 1 and add value 1. Value 1 means here I have taken value 1. I am considering value 1. So just pass your value and store and sum it up in your answer variable. Then return your answer. And we have some overlapping subproblems with I and previous. And I also have to take modulus. So let's take modulus, mode, here mode, and next we have dp. So find your maximum value, then this maximum plus 1. Next, store your value, and if it is not null, so return your value. So this is the memoization code. So it's time to convert into a tabulation code. I have taken some values, mode, maximum, and this. So we are starting from 0 and reaching n. So for tabulation we have to start from backwards. we have to know the next value beforehand. So start from backwards. I. Next we have previous. We are starting from 0 and reaching till maximum value. We are starting from 0 and here I am passing value 1. Value 1 can be our maximum value. So value 1 can be our current value. So either I can start from current value to 0, or I can start from 0 to current. This for loop will work. And if you write AI first, AI here, and you want to reach 0, so and you decrement your previous one, so this for loop will also work. Next, all these things we have to write here. So just write here this condition, but we need to make sure. uh, so we have here dp I plus 1, and value here it is value 1. But I plus 1 we have this. uh, Suppose we are at the last index, so I plus 1 will not work. We will reach n. So if we reach n, so we have to take 1. That's one thing. If I plus 1 reaches n, then take 1, either this value, and at the end return 0 0. So I did a mistake here. I forgot to fill out my value. So after iterating, just fill your value and just give it a run. Yes, let's submit this. So we have solved this question using tabulation and memoization. So there's a second version. This is number pairs 2. In this, a constraint is bit on a higher side. So if you want to know how to solve this question, I will link this in the description or in the I button. So just click there and you will reach this question. And thank you all for watching.